Good morning, students. My name is Abhishek Sachdeva. I am from Lalpur Khalsa College of Engineering, Department of Civil Engineering. And students, this is the lecture for Civil 4th semester class, and the subject is Concrete Technology. So, students, earlier in the previous lecture, we have discussed the different grades of concrete, the mixed design of that various grades of the concrete using the Indian standard methods, and now we will discuss the strength parameters, how to test the particular grade of the concrete, as we have designed the concrete for target mean strength, or if we are talking about the characteristic mean strength. So students, that basically it is the 28 days of the compressive strength in Newton per mm square, and that compressive strength, how it is calculated, how it is obtained, that we will be going to discuss in this current lecture. So, compressive strength. Student, compressive strength is the capacity of material or structures to withstand actually directed pushing forces. So, basically, when the limit of compressive strength is reached, brittle materials are crushed. The compressive strength is used to determine the hardness of cubical and cylindrical specimens of the concrete. So basically, students, the compressive strength of the concrete test, it provides an idea about all the characteristics of the concrete. By this single test, one can judge that whether concreting has been done properly or not. So basically, the compressive strength is the ability of the material or the structure to carry the loads on its surface without any crack or deflection. A material under compression tends a material under the compression, it tends to reduce the size, while in tension the size elongates. So compressive strength, we will be determining the capacity, we will be determining the ability of the material or the structure to carry the load on its surface without any cracks and the deflection. So the strength of concrete specimen depends upon various factors that are cement aggregate, bond, then water cement ratio, curing temperatures, and the size of the specimen. Right? So it depends upon many factors, which are including the water cement ratio. The major factors, they are the cement strength, the quality of the concrete material, quality control during the production of the concrete, etc. And the cube specimens is of size of 15 by 15 by 15 centimeter. If the largest nominal size of the aggregate does not exceed 20 mm, the size 10 centimeter size cubes may also be used alternatively for the measurement of the compressive strength. Cylindrical test specimens have the length equal to twice the diameter. They are 15 centimeter in diameter and 30 centimeter long. So this is basically the uh, molds. This is basically the specimens for the compressive strength test. So it may either be the cube or it may be conducted on the cylindrical specimen. Cube having the dimension of 15 centimeter, 15 centimeter, and 15 centimeter, and the cylindrical specimen having the dimension of 15 centimeter in diameter and 30 centimeter long. So this is the specimen for the compressive strength test. For most of the works, cubical molds of size 15 centimeter by 15 centimeter by 15 centimeter are commonly used. So basically, I'll give you an idea ki what basically is done for this performing the compressive strength. The concrete is poured in the mold and tempered properly so as not to have any voids. After 24 hours, these molds are removed and test specimens are put into the water curing. The top surface of these specimens should be made even and smooth. This is done by putting cement paste and spreading smoothly on whole area of the specimen. After that, the specimens are tested by compression testing machine. After 7 days of curing or 28 days of curing, load should be applied gradually at the rate of 140 kg per centimeter square per minute till the specimen fails. Load at the failure divided by the area of the specimen gives the compressive strength of the concrete. So this is basically the general idea how we obtain the compressive strength of the concrete. So the detailed test procedure is here, and I'll explain you the whole procedure. Students, before this test procedure, the mixing of the concrete for cube test is also important. So the mixing, it can be the hand mixing, right? Or it can be the mixing sampling of the cubes for the test. So mixing of the cement and fine aggregates on a water-tight non-absorbent platform until the mixture is thoroughly blended and is uniform color. Then add the coarse aggregate and mix with cement and fine aggregate until the coarse aggregate is uniformly distributed throughout the batch. Then finally add water and mix it until the concrete appears to be homogeneous and of the desired consistency. So this is the mixing portion. Now the procedure includes, first of all, scope. The test method covers determination of compressive strength. Obviously, we are determining the compressive strength of the cube. It consists of applying the compression axial load to molded cubes at a rate which is within a prescribed range until the failure occurs. So, the compressive strength is calculated by dividing um, the maximum load attained during the test by the cross-sectional area of the specimen. So this is the scope. Then if we are talking about apparatus, then weighing device to weigh different ingredients of the concrete, tools and containers for mixing. We need to mix that ingredient, so that for that we need the tools, right? Then tamping rod, 16 mm diameter and 600 mm in height. Then compression testing machine. Then cubes, that is of 1 mm, 150 mm size. So this is the materials which are required, the apparatus which are required for the compression testing. So prepare a concrete mix with the proportion suggested or as per the mix design, right? So then prepare 3 testing cubes. It may be 6 also. We should try to cast the cubes maximum of 6 in numbers, as we can test 3 cubes at 7 days and 3 cubes at 28 days. If we want to go beyond to these curing edges, then we need to cast more number of cubes. Metal molds should be sealed to their base plates to prevent the loss of water. So the step by step, if we move, initially remove the specimen from the water, fill the cubes in 3 layers, tamping each layer with 35 strokes using the tamper or the tamping rod. We need not to fill the complete cube in one. It should be filled in 3 layers, and after every layer the compaction is done by using the tamping rod, and it may be used 35 times for tamping after every layer. Then fill the mold completely, smooth off the tops evenly, and clean up any concrete outside the cubes. Leave the specimen in the curing room for 24 hours. So this is basically the procedure. After that open the molds and immerse the concrete cube in water basin for 7 days or 28 days of the curing, and before testing ensure that all testing machine bearing surfaces are wiped and clean. So students, that cubes which we have casted that need to be immersed in the water baths or the curing tanks for 7 days. If we want to get the strength after 7 days, we need to take out the cubes after 7 days, and if we want to get the strength after 28 days, so we need to take out the cubes after 28 days of the curing. Before testing, ensure that all the testing machine bearing surfaces are wiped off and clean. They should be clean after the testing is done or after the concrete it has been formed. Carefully center the cube on the lower plate and ensure that the load will be applied on the two faces, opposite cast faces of the concrete. So we need to place that cube into the compression testing machine. Without shock, apply and increase the load continuously at a nominal rate within the range of 0.2 Newton per mm square to 0.4 Newton per mm square in the second until no greater load can be sustained. So load should be applied gradually. The load it should be applied gradually at the rate of around 150 kg per centimeter square per minute till the specimen fails. So this is the gradual application of the load over the specimen when the specimen is fitted in the compression testing machine. So this is the compression testing machine. It is covered from the front because after the crushing, when the cube it is about to crush, we are not able to get the face the crushed material, so it is covered with the shield. So this is basically the procedure. When we are applying the load gradually, the concrete cube it is pressed, it is crushed, and we are able to get the ultimate load which that concrete cube it has attained. So students, remove the specimen from water after specified curing time and wipe off excess water from the surface. Take the dimensions of the specimen to the nearest of 0.2 meter. Clean the bearing surface of testing machine. Then place the specimen in the machine in such a manner that the load shall be applied to the opposite sides of the cast cube. Align the specimen carefully on the base plate of the machine. Rotate the movable portion gently by hand so that it touches the top surface of the specimen. Apply the load gradually, right, as I have told you, at the rate of 140 kg centimeter square per minute till the specimen fails. Record the maximum load. Now when we have placed the concrete cube in this compression testing machine, record the maximum load and note any unusual features in the type of failure. So minimum 3 specimens should be tested at each selected age. If strength of any specimen varies by more than 15% of average strength, results of such specimen should be rejected. Average of 3 specimen gives the crushing strength of concrete, and how we are calculating that crushing strength of the concrete, how we are calculating that compressive strength. So you can say this compressive strength it is equal to P divided by A, and we will get the result in Newton per mm square, where P is the applied load and A is the area of the specimen. So students, how we are going to calculate the compressive strength? Compressive strength it will be equal to the load divided by the area. Compressive strength it will be equal to the load divided by the area. So load, how we are getting this load? We are getting this load from the CTM value, maximum load at which the maximum load at which the our concrete fails or cube crush. That load is taken as the load over here, and area is the area of the cube. That means 15 centimeter into 15 centimeter, so it will be 150 into 150, so that will be the area. And load, it will be, we are getting the maximum load applied from the testing machine. So this will give us the compression testing value. So you can see the students, before loading the specimen is placed over here, and after the loading the concrete cube crushed, and we are able to get the value of the maximum load which has been taken by this cube, and that load, it will be used in the calculation of the compressive strength, that is equal to the load divided by the area, and we will be getting the compressive strength of the cube in the Newton per mm square. So this is compressive strength of the concrete. Thank you.